In this video, we're going to talk about quadratic equations. We've already discussed what quadratic functions are, or quadratic expressions are. Now let's talk about equations that involve quadratic expressions. And so quadratic equations are equations of the form ax squared plus bx plus c equals 0. Remember, anytime in math that we say that something can be written in the form, we can rewrite it using some algebraic manipulation so that it looks like this, right? And when push comes to shove, it's a polynomial of degree 2, and you have potentially 3 terms. Each term may have a coefficient a, b, and c. Of course, if a was 0, then it wouldn't be quadratic, it would be linear. And so we add the fact that a, b, and c can be any real number, except for a has to be any non-zero real number. And so there are multiple methods that we can use to solve quadratic equations. One of the most useful methods, which is one of the reasons why we like to factor, is to use factoring in order to help us solve, right? Whenever we solve a quadratic equation using factoring, what we like to do is to write the quadratic in the form ax squared plus bx plus c equals 0. That means get all of your terms on one side and 0 on the other side of the equation. That way we can factor, all right? So once everything is on one side, that's step 1. We're going to factor the polynomial completely. Once we factor the polynomial completely, we're going to use the zero factor property to set each factor equal to 0, right? Remember, this is basically I'm going to use I'm going to use capital A and B. If I have A times B equals 0, then by our multiplicative identity, actually, this is not the multiplicative identity. We just know that when I have two numbers that are multiplied and the product equals 0, either A has to equal 0, or one of the numbers has to equal 0, or the other number has to equal 0, or they both can equal 0, right? And so once we factor completely, we'll have a product of two binomials or two smaller order degree polynomials equal to 0. And so this third step is to set each of those equal to 0, and then we'll solve the resulting equations, right? And so here, let's get all of our terms on one side so that we can write our polynomial in this form here. That means we're going to subtract 8 from both sides. Then we're going to get to the point where we can factor. Well, that's a trinomial there. The highest exponent is 2, is quadratic. I need to find two numbers that multiply to give me -8 and add up to 2. So I can use a +2 and a +4 and a -2. And so I have x plus 4 times, that's understood to be a multiplication there, times x minus 2 equals 0. And so what I'm going to do is use my zero factor property here to say that either x plus 4 equals 0 or x minus 2 equals 0. Let's solve this for x. And so we get two solutions, -4 and 2. All right, so this is one method that we can use to solve quadratic equations. Let's go to another method. The other method is to solve the quadratic equation using the square root property. All right, the square root property is used for very specific quadratic equations, right? We have to ensure when we're using this method here that either we see that there is no linear term explicit in the quadratic equation, or we rewrite it so that we don't explicitly see a linear term. As you may recall, right, this is the quadratic term. This is what makes it a quadratic equation. This term right here with x to the first power is your linear term, and this term right here is your constant term, right? And so if we don't see a variable or a variable expression raised to the first power, this is a good setup to use the square root property, all right? And so this is how the square root property works. What we do is, once we know that we can use the square root property, we're going to isolate the quadratic term, right? The term that has the variable expression squared, right? So if you look at this example here, notice there is no no linear term. There is no x to the first power or some coefficient times x to the first power here. So this is a good setup. We're going to isolate the quadratic term. That means to get it on one side by itself. So we need to undo this subtraction by 25 by adding 25 to both sides. And once we get this isolated, this quadratic term isolated, we need to undo squaring, right? To undo squaring, we take the square root. So that's the square root property, which is why this is called square root property. We take the square root of both sides. And one of the things that people often forget is that when we have variable expressions, remember, variables can equal both positive and negative numbers, right? Well, when we take the square root of x squared, the square root and the square cancel, and we're left with actually absolute value of x. And the square root of 25 is 5. Now, no one, well, I won't say no one, hardly anyone writes this way. What people usually say is, oh, well, I know how to solve a quadratic equation, right? In order for me to drop the absolute value symbol, in order for me to drop that absolute value symbol, I know that this is saying find the x values that are 5 units from 0. And so we can say that x equals 5 or x equals negative 5. And that would be the solution to this quadratic equation, this absolute value equation. Well, what people usually say is when you take the square root of both sides, just remember to put on the plus or minus to the other side, and that takes care of this step right here. So a lot of times when we solve quadratic equations, or when we see people solve quadratic equations, they skip this step here, and they just add on a plus or minus here. This is where that plus or minus comes from. It's because the square root of x squared is actually equal to the absolute value of x. If we don't include this absolute value, or if we don't include this plus or minus, we're going to be missing one of the solutions. And so this is the solution to our quadratic equation. Note here that I can put in both a positive 5 and satisfy this equation, and a negative 5 to satisfy this equation. All right, that's solving using the square root property. The next method is called completing the square. Before we get into completing the square, I want to review something with you. And this thing that I want to review is called a perfect square trinomial. All right. Perfect square trinomials, right? So I'm going to write a perfect square trinomial here. All right. The polynomial x squared minus 12x plus 36 is called a perfect square trinomial. The polynomial x squared plus 8x plus 16 is called a perfect square trinomial. The reason why it's called a perfect square trinomial is because if I factor it, there's a 1 in front of my x squared, so I put x's here. Two numbers that multiply to give me 36, but add up to a negative 12, negative 6, and negative 6. We could write that as x minus 6 quantity squared. This one right here is a perfect square trinomial because when I factor this, two numbers that multiply to give me 16, but add up to 8 is 4 and 4. And so I could write that as x plus 4 quantity squared, right? And so these polynomials, when I factor them, they factor into a squared binomial or a perfect square, all right? This is why we call them perfect square trinomials. Now, what I'm going to do here is I'm going to erase this part right here since I'm going to run out of space. I want to look at the pattern of what this polynomial looks like, all right? I want to look at the pattern of what these two polynomials look like because it'll show us how we can complete the square, all right? And so if I look here, for instance, both of them begin with an x squared, right? So this has an x squared term, this has an x squared term as my leading term. Notice here, this negative 12 and this 36 have a relationship. It just so happens that if I take half of that negative 12 and square it, negative 12 divided by 2 is negative 6. If I do negative 6 squared, I get a positive 36. Same thing happens with this 8 here. 8 divided by 2 is 4. If I square that, I'm going to get 16, which is sitting there, right? And so what happens with perfect square trinomials is that perfect square trinomials are always in the form x squared plus bx plus b over 2 quantity squared. This is what makes a quadratic polynomial with a leading coefficient of 1, a perfect square trinomial. And so we can use this in order to help us factor. These always factor into x plus b over 2 times x plus b over 2, or you can say x plus b over 2 quantity squared, right? My b over 2 is this number here, which is the -6 here. Remember, we factored that into x minus 6 quantity squared. My b over 2 here was 4. Remember, we factored that into an x minus 4 quantity squared, right? And so, all right, that was supposed to be a plus 4 because this was positive in here. And so what we're going to do here is we're going to solve quadratic equations using this method. One of the things about these last two methods here, the square root property only works if you don't see a linear term, right? If you don't see a linear term, all right? That's initially. Factoring doesn't always work because not all polynomials are factorable. Some of them are prime. And so these two methods may not work for every single polynomial. You may have to do some extra work to make the square root property work for other polynomials, which is exactly the completing the square technique, which we're doing here. The completing the square technique uses the square root property, and this always works, no matter what polynomial you're given. But what we're going to do is we have to make sure that we have our polynomial written so that there's a 1 in my leading coefficient, and we just need these two terms here in order for us to complete the square. All right, so we need a 1 as our leading coefficient, and we need these two terms in order for us to complete the square, so that if we don't have a perfect square trinomial, we can just add the b over 2 squared in order to get this third number here, so that we can factor into a perfect square. And so these are the steps that I recommend. We get the variable terms on one side and the constant terms on the other. We multiply or divide both sides to obtain a leading coefficient of 1. Again, remember, we needed a 1 in front of the x squared. That's our leading coefficient. We're going to add b over 2 quantity squared. Remember, we did -12 over 2 quantity squared. Got the 36. That b comes from that standard form in which we write polynomials or quadratic equations. Ax squared plus bx plus c equals 0. We take half of the b over 2. We square that, add it to both sides. We factor, and then we're going to get something squared equals some number, right? And this is going to have our variable in it, right? So if we want to undo that square, we can use the square root property method, which we just learned, to take the square root of both sides. Remember, the square root equals absolute value, or you can remember to put on the plus or minus, and then you'll be able to solve that equation fully. And so we're going to look at this polynomial here, this quadratic equation here. Highest exponent is 2. There's an x term, so I'm not going to use the square root property just yet. I'm going to use completing the square. My variable terms are on one side, my constant term is on the other. I need to multiply or divide so that I have a 1 in front of my x squared. So I'm going to divide both sides by the same number that I need to divide this expression by to get 1, and that's to divide both sides by 3. I get x squared minus 4x equals 3. Now, what I need to do here is I need to make this a perfect square trinomial, right? Perfect square trinomial means take half of b and square it. The value in the place of b is a -4. -4 divided by 2 is -2, and if I square that, I get a 4. So what I'm going to do is I'm going to add 4 to both sides, because if you add it to one side, you got to add it to the other side so that your equation stays balanced, right? And so if I factor this, I'm gonna have to find two numbers that multiply to give me 4, but add it to a -4. -2 and -2 work. 3 plus 4 is 7. And so I can write this as an x minus 2 quantity squared equals 7. All right. With this, let's take the square root of both sides. This actually equals absolute value, but I'm going to put the plus or minus on the other side to represent that I know that I took an absolute value. And then the last thing for me to do is to add 2 to both sides. And so I get 2 plus or minus the square root of 7. So one of my solutions is 2 minus the square root of 7. My other solution is 2 plus the square root of 7, if you want to write your answer as a solution set. So that is solving by completing the square. Let's go to the last method, which is probably the most popular method. Like completing the square, this method always works because it is actually derived from completing the square. What we have to do to solve our polynomial equation, our quadratic equation using quadratic formula, is to write the equation in standard form, ax squared plus bx plus c equals 0. So almost the same form as we did when we were factoring. Then we're going to use the quadratic formula to find all of our solutions. Our quadratic formula is given here. X equals negative b plus or minus the square root of b squared minus 4ac. All of that is over 2a. All right, and a, b, and c are the same as your coefficients that are given here when your equation is written in standard form. And so let's solve the same equation that we solved using completing the square using the quadratic formula. We've got to get everything on one side and 0 on the other. So I'm going to subtract 9 from both sides. My a is 3, my b is a negative 12, and my c is 9, right? And so I'm going to get all of my solutions by doing a negative b, so a negative 12, plus or minus the square root, negative 12 squared, minus 4 times a, which is 3, times negative 9, which is c, all over 2a, so that's 2 times 3. Okay, so this is just as simple as plugging in values into a formula. And so what we're going to do now is we're going to simplify everything. And so I have a 12 plus or minus the square root of 144. 12 times 9 is 108, and that's a negative 9, so that'll be a negative 108. So I'm subtracting a negative 108. That's the same thing as adding 108. So I get 12 plus or minus. If I add those values together, that's 252. All right, and I want to simplify this, right? I need to simplify this, right? So I think about my list of perfect squares. I think the largest perfect square that goes into 252 is 36. It's 36 times 7. And so I get 12 plus or minus. Well, the square root of 36 is 6. Square root of 7 over 6. And since this is division by a single term, I can divide both of these terms by 6. When I divide 12 by 6, I get 2. And when I divide 6 square root of 7 over 6, or by 6, I get the square root of 7. This is the exact same value we got when we did this by completing the square. All right, and so we can use our quadratic formula for any quadratic function equation. We can use completing the square for any quadratic equation. We can use the square root property when there's no linear term. However, if we go through the process of completing the square, there is a step where we use the square root property. So you can almost say that you can use the square root property almost any method, but you can't have a linear term, all right? And then factoring, if I can factor, I'm going to try to factor, especially the simple ones that are factorable with a 1 in front of the x squared. I'll choose factoring before I choose any of the other methods because they take a longer process. All right, but that's the end of this video. I'll see you during our next video.